Hi class, this is course 3, lesson 15, powers and roots. So powers are used to show repeated multiplication. Okay, so we're going to use exponents, and those are the same thing as powers. So a base is the number 8, and then the 2 is the exponent in my example here. So what this means is that we're going to multiply 8 twice. We're going to use the 2, or the exponent tells us the number of factors, okay, or the number of times the 8 shows up. So this is 8 times 8. That's twice. That's the exponent. In this case it would be 64. Now when you see an exponent of 2, you can also say, instead of 8 to the second power, you could say 8 squared. And if you have an exponent of 3, you'd say cubed. Those are appropriate. If it's a 4 or higher, you say whatever number to the 4th power or number to the 5th power. Okay, so like this one is 10 to the 5th power. And if we evaluate that, we are just writing a 10 down 5 times. 1, 2, 3, 4, 5. So 10 times 10 times 10 times 10 times 10. Now with powers of 10, that's really easy. You just write a 1 down, and then how many zeros do you have? 5, 2, 3, 4, 5. Okay, if this were any other number, we would just multiply it, and then multiply it again, and then multiply it again. Sometimes it gets tricky. You forget that the first time you multiply, you're actually multiplying twice. So watch out for that. Make sure you count how many times it's the number is being used in your multiplication. Right, the prime factorization of 40 using exponents. I think a number of you are already doing this. So use prime factorization. I like factor trees. If you want to do division by primes, that's fine. But you work this through and remember that my example is 4 times 10, but yours could have been 8 times 5 or 2 times 20. All of, no matter which way you go, we all get the same, to the same place. So this would be 2 times 2 times 5 times 2. So there are 3 2's here. 2 times 2 times 2 times 5. So since the 2 is there 3 times, I can write that as 2 to the 3rd power, or 2 cubed times 5. Another example, if you're given a square that is 1 foot on each side, find the area in square inches. Okay, first off, they tell us feet, they want inches. Okay, so watch for those types of problems. And then I always like to just draw a picture. This is 1 foot by 1 foot. And if I were to change that, I can think through my conversions, and I know that 1 foot is really 12 inches by 12 inches. And I know that area is, let's see, this is a square, so area is side length squared. So this is area equals 12 squared, because remember they wanted inches. And so area equals 12 times 12, and you know that that is 144. And then remember to label square inches. Okay, well, another thing that we can do with exponents, even though it's really similar, is that when we write out variables, they can have exponents too. And so if we're given an expression, we can use exponents to make it smaller, to make that expression look smaller. So we need to look at this and say, well, 7 is there once, but the x is there how many times? 1, 2, 3, 4. So I'm going to write a 4 there just so I keep that track or straight. And then y is there twice, and z is there once. Okay, and you may also remember that even though the 7 is just a 7, the exponent is 1. Okay, so it has a hidden exponent of 1, and when it's 1, we don't write it. Okay, so where I'm getting at that is we have z to the 1 power. We don't need to worry about that. So to make this a little smaller, we're going to write 7, and then we have x. And how many times is x a factor? It's 4. And then how many times is y a factor? 2, and then z, and we don't put the 1 there. So it's 7x to the 4th power y squared z. And we can do this because it's repeated multiplication. Okay, make sure that you remember that. Exponents, repeated multiplication. If there's addition in there, we're not using exponents. Okay, now the inverse to using powers or exponents is taking a root of a number. And remember that inverse means it's going to undo. Okay, it's the opposite. Or what operation will undo using powers? That's taking the root of a number. And a couple things that you need to know is that a root looks like this. Okay, this is called a radical. And whatever number goes under here is called the radicand. Okay, so we have a radical, that's the symbol, and the radicand is the number under the radical, or the number that you're trying to determine the square root of. Okay, this one is a square root. We also have radicals that look like this. There might be a 3 there. That's the cube root. Okay, this, the regular one, is just a square root. Okay, so what's going on here is that we have this 2, there's an implied 2. There's a 2 there, but it's invisible, or it's implied. And then there's a 3 here. Those are the indices, the index. So that's the index. We'll use the singular. That's the index. That tells you what it was to begin with. Was the item squared? Was the item cubed? The number that's underneath the radical. So so we have square root, we have cube root, and then if it's a 4 or higher, we just say the 4th root, the 5th root. And so how this works, let me use the black ink so that we can do a couple examples here. So if we have the square root of 49, we're asking ourselves, what number did we square to get 49? And it's not divided by 2, and that's a common error. It's what number times itself. So number times a number gives you 49. And hopefully you know that x here in this case has to be 7, because 7 times 7 equals 49. Well, the same thing works, or it works the same way when you have a cube root of like 64. So what number did you cube? So what number did you multiply times itself 3 times to get 64? Well, I think if you think about this, you can put a 4 in there. 4 times 4 is 16, and 16 times 4 is 64. So x has to equal 4. These may take a little bit more thought, but remember that you're not dividing. You are figuring out what number you multiply times itself to get that number. Okay? Make sure you write down any questions you have about that, and we'll talk about it in class. I do have one more thing. You might be given an area problem in reverse. Okay, so you know the area of a square. So let's say the area of a square is 25 square centimeters. If they want to know the length of a side, what would you do? Well, if they want to know the length of the side, remember that when you took the square, you took side length times side length, side squared, which would have been in this case 25 centimeters squared. So we need to undo the squaring process. And so what we're really asking you to do here is to work backwards and take the square root of the 25. And technically you're taking it of the centimeters squared also, because you did centimeters times centimeters. So what's the square root of 25? It's 5. And centimeter times centimeter, so the square root would be centimeter. So each side length is 5 centimeters. So hopefully that made some sense. There might be some questions that you have about that. That's fine. Just make sure you let me know what they are. I'll be glad to help you. Okay? That's it for lesson 15. I will see you in class.